So in this video, we're going to be introducing point-slope form. So we're going to be going from, if we know the slope of a line and a point it goes through, we're going to be rewriting that information in point-slope form. Next up, let's say we have a situation, some information, some sort of application where we know a rate, 60 meters per second for an example, and we know another piece of information that happens in the middle of the story, not the start amount, we're in the middle of the story. So like in this case here, 20 seconds, 1,000 meters, we're going to rewrite this information in point-slope form. Next up, if we do have an equation in point-slope form, we're going to be looking at a strategy for graphing. So let's look at real quick the difference between slope-intercept form and point-slope form. So first up, the m, the value in front of the x, the coefficient, that is still going to be the slope whether you're in point-slope form or slope-intercept form. Now remember, in slope-intercept form, this constant term here, what's being added or subtracted to the variable, that's going to be the value of your y-intercept. We don't have that with point-slope form, but what we do have is this x1 and this y1 is going to be a point on the line. So somewhere along that line, you're going to have a point, and that's the point you're going to be using. You might have multiple ones to choose from as well. Now, there is another version of point-slope form, which I'm not going to be going over in this video, but it looks like this instead of this here. This one has y equals m, x minus x1 plus y1. And on this one here, the y1 is scooted over or transposed over to the left-hand side of the equal sign. Now, just as a big picture type idea, there's also another common linear equation, and that's standard form, ax plus by equals c. We're not going to be going over this one in this video, but just wanted to put that out there so that way you kind of have a big picture type idea of the three main linear equations. So let's go ahead and look at an example here. We're going to write an equation of a line. It has a slope of 2 and it passes through the point -3, 4. So the information that's given to us is we have a point and we have the slope, so we are going to use point-slope form. So remember that m, that is going to be the slope. It says right here that's going to be a 2, so the m gets replaced with a 2. And then the x1, y1, remember that's a point on the line. So in this case here, x1, y1, the x1 is going to be replaced with a -3 right there. And then the y1 is going to be replaced with a 4. We normally don't do minus a negative, so we're going to go ahead and clean this up a little bit. There, minus a negative is basically the same thing as just plus. So there, we're done. Unless, now you got to make sure you read the instructions. If it asks for an equation, boom, you're done. However, if it asks for an equation in slope-intercept form, we still have more work to do, but it's not super duper tricky. So here we go. So here's our equation in point-slope form. In order to change it into slope-intercept form, we're just going to simplify. So here we go. So for simplifying this, we have distributive property with the parentheses here times the 2. So 2 times x, 2x, 2 times 3, that's going to be a +6 there. And then we still have the +4. Next up is just to add like terms, right? So as far as x terms, we only have one term that has an x, so 2x stays there. And then for constant terms, we have a 6 and a 4. Added together makes 10. And there's your slope-intercept form there. Remember, from slope-intercept form, that's going to be your slope. And now we have some new information that we didn't have over here. We also have the y-intercept. Let's have you go ahead and try this one out on your own. Pause the video, then come on back, see how you did. So the information that's given for this, writing an equation of a line with a slope of 1/2 through this point here, 6, -1, the information is a point and the slope. So we are going to be using point-slope form. So remember, point-slope form, that m there, that's going to be replaced with the slope. Says right there it's a 1/2, boom. And then the x1, y1, that's this point right here. There's our x1, there's our y1. So the x1 is going to be replaced with a 6, boom, there it is. And then the y1 going to be replaced with a -1. Or in this case here, we're going to change it to a -1. And there, you're done. Again, unless you need this in slope-intercept form, make sure and read the instructions. So for changing it into slope-intercept form, you're just going to simplify this equation here. So first up, we're going to distribute that 1/2. 1/2 times x, 1/2 x. 1/2 times -6, well, 1/2 of 6 is 3, so that'll be a -3. And then we still have the +1 here. Next up, add like terms. So as far as x terms go, we only have one term with an x, so that's going to stay 1/2 x there. And then a -3 plus a 1, you have to pay $3, but you only have $1. You don't have enough to cover it, so we know it's going to be a negative. And then 3 and 1, the difference between those is going to be a 2 there. Now, there's your answer there in slope-intercept form. Now, there is another way of finding this y-intercept piece here, or going from point slope form to slope intercept form. So here we go. So this is going to be, it's a little less obvious, but it is faster. So remember, here's our point slope form, and we want to go into slope intercept form. Well, remember the m, that's going to be your slope, and the b is your y-intercept. Well, we already know the slope. It's right there. It's 1/2. So we can go ahead and just replace the 1/2 into this box right here. Boom, there's our 1/2. Now the only information we actually need to figure out is the y-intercept, okay? So remember the y-intercept, that's a coordinate point. It's 0, b. So remember 0 goes in for your x, and then this y value, that's just going to go there. Well, 0 for x, we know that. We can actually do that. We can put 0 in for x right there. Boom, there we go. So now we can just do, simplify. We can do order of operations. That's what we're going to do here on the right-hand side of the equal sign here. So parentheses first. Remember PEMDAS, parentheses first. So that's going to be the 1/2 stays there. Parentheses, 0 minus 6 is just -6. And then we still have the plus 1. So now we do multiply, right? PEMDAS, parentheses, exponents, multiplication, division. We got multiplication, division next. So 1/2 of -6. Well, that's a -3. 1/2 of 6 is 3. And then next up, or last up, we just add. -3 plus 1. Well, that's just going to make a -2. And there we go. So that's another way of doing it. We can do this mentally using mental arithmetic as well. So remember, we're trying to find the y-intercept right there. Remember, 0 goes in for x, so we're just going to kind of ignore that x there, and we're just going to, in our brains, go from x minus 6, well, x is 0, so we're just going to go down here to the -6. So really all we're doing is 1/2 times this number and then plus this number here. So we're doing 1/2 times -6 plus 1. So it is a little bit faster. We can do this in our heads using mental arithmetic, and these can go pretty stinking fast after you kind of get the pattern figured out. So now we're going to write an equation for this situation here. So we're on a bicycle. Alexia averages 4 miles per hour riding away from her house. After riding for 2 hours, she's going to be 15 miles away. So again, we got to look at what information is given. We have a rate. That's kind of like a slope type idea. And then we have another piece of information in the middle of our story. We got 2 hours. She's 15 miles away. So we have kind of a ordered pair or a coordinate here or a point along our story, not at the beginning though, and we have a rate. So that's going to be point slope form. Here's our point and here's our slope type idea. Again, we're kind of translating from words back to like math lingo. Okay, so in this case here, we are using m for miles and h for hours. Sometimes you'll see here, this will be d for distance because m is kind of there, so it can kind of be confusing, but it's going to be here instead. And then t for time is super common instead of h for hours. So anyhow, the m, that's your slope or your rate. So in that case, it says it right there, 4 miles per hour, so that's going to go there. And then our x1, that's our independent variable. In this case here, that's going to be the 2. So that's going to go there for x1. And then our y1 is going to be replaced. Our dependent variable is the m for miles. So 15 miles is going to go there. It's going to replace the y1. Okay, and we're done. Again, sometimes these questions are going to say, hey, actually, we want this equation in slope-intercept form, so we do need to do a little bit more work. So again, there's 2 ways of doing this. We can just simplify it, right? So in this case here, we have distributive property here. 4 times h is 4h. 4 times -2, that's going to be a -8 there. And then we still have the plus 15. Now we're just doing add like terms, h terms, variable terms. We only have this one here. It's the 4h. And then we have a -8 plus a 15. So we're thinking like subtraction type thing. We owe $8 and we have 15. So we're just going to go 15 minus 8 to figure out how much we have left after paying our debt. So there we go. There's our slope-intercept form. Remember, 4 is going to be our slope, and then 7 is going to be our y-intercept. Now remember that y-intercept, there is a shorter way of doing that. So in our brains, we're just doing 4 times -2, and then plus 15. So 4 times -2, that's -8, plus the 15. And the reason why we can do this like shortcut type idea is that the y-intercept is when the x is 0. In this case here, that's going to be the h. So we're pretending the h is 0. So we just kind of, in our brains, ignore it. 4 times -2 plus 15. And boom, there we go. So let's have you go ahead and try this one out on your own, then come on back and see how you did. So looking at the information given, we have a rate or a slope type idea, and then we have another piece of information in the middle of our story. We got day 7, 55 puppets remaining to sell. So if we knew the start amount, we'd use slope-intercept form, but we don't. We have information in the middle of our story, so we're going to use point-slope form. There's our point, there's our slope, so point-slope form. So in this one here, we are going to use D for days and P for the number of puppets remaining. So P is going to be the dependent variable because number of puppets depends on how many days he has been selling. So in this case here we go. So M is the slope or the rate. So in this case here, he is selling puppets. So he's getting rid of 6 puppets per day. So that's going to be a -6. This tends to be a little on the tricky side. Got to make sure you know what we're looking at here. Number of puppets remaining is going down by 6 every day. And then for our information, the number of days goes with our independent variable, number of days. So that's going to be a 7 there. There's day 7. He's going to have 55 puppets remaining to sell. Again, this is going to be done unless the instructions are asking for slope-intercept form. So if you need to go from point-slope form to slope-intercept form, just simplify. In this case here, distributive property first. Remember, there's 2 ways of doing it. This is kind of the longer way. So that's going to be a -6 times d for our distributive property. So that's -60. And then -6 times -7. Negative times negative is positive, 42. And then we still have the plus 55. Now that we've distributed, now go ahead and add like terms. We only have one term with a variable, -6d there. And then we have 42 plus 55 here. This one's not too tricky to do. Just pretend this is like a 45. 45 plus 55 is an even 100. Well, the 45, the 42 is 3 less. So our sum is going to be 3 less than 100 there. So there, we're done. Now remember, this is slope-intercept form. We know what the slope is, and we know what the y-intercept is. In this case here, that's our start amount. So we know he started with 97. So remember, the shortcut for this is just knowing that I can just take this from over here, right? -6 is my slope, -6 is my slope there. And then for my y-intercept, to find that, 0 goes in for the d, so we're just doing -6, ignoring the d, -6 times -7, and then plus 55. So this is the arithmetic that we're doing to find that y-intercept. Just put 0 in for your independent variable or the x variable. So now we're going to be graphing equations from point-slope form. So here we have an equation. It's in point-slope form. Remember, point-slope form, m, x minus x1. We got the parentheses there, then plus another number, plus the y1 there. So going back through, remember that m right there, that's still slope, same as if it was in slope-intercept form. And then this x1, y1 here, that is a point on the line. So now let's look at the equation that we're going to graph, right? That -1/2, that's going to be our slope. And then the point on the line is going to be a -3, 1. So remember this plus here, it's minus a -3. It's got to be minus. So in our brains, we're switching the sign, right? So it's minus a negative is mathematically what it is, but in our brains, we're thinking, oh, I'm just going to do the opposite of whatever this is here. So instead of a +3, it's a -3. If this was a -3, then it'd be a +3 here. Okay, so our strategy for graphing, here we go. We're going to start with the point, right? So for this one here, that the point is -3, 1. So -3 on the x, +1 on the y, boom, it's right there. Next up, we're going to apply the slope. Remember with slope, in this case here, it's a -1/2. So we are thinking with slope, we're thinking rise over run. So the negative, when we're thinking rise over run, is going to go with a numerator. So that's going to be a -1/2. So that's going to be a down 1, and then it's going to be to the right 2. Okay, so down 1, right 2, -1/2. And there's our second point there. And now we just connect the dots and draw our line through both points. And boom, there is our graph. Let's have you go ahead and try this one out on your own. Pause the video, then come on back and see how you did. So we do notice that this equation is in point-slope form, m, x minus x1 plus y1. Okay, so remember that m, that's going to be our slope. and then the x1, y1 is a point on the line. So there's tons of points on the line, but this is the one we're going to be working with. So for our equation here, starting with a point, so what's the point we're going to be working on here? Well, that's going to be positive 1, negative 3. So remember, if it's in the parentheses, in our brains, we're just switching it from a minus to a positive or vice versa. If it's a plus there, then it's going to be a negative there. If it's in the parentheses with the x, okay? Because this is minus a positive 1. Minus a positive 1, okay? So anyhow, 1, negative 3, that's where we're going to start right there. So that's going to be 1 on our x, go down 3 for negative 3 on our y. There's our first point. Next up, we're going to apply the slope. So in this case here, the slope is a 2. Now we are thinking rise over run. So that's going to be up 2 and then to the right 1, right? So in our brains, it's 2 over 1. So that way we can do rise over run. And there's going to be our second point there, and draw the line through both points, and boom, there's our line. So quick wrap up here, right? Point slope form, that's this version that on this video here is going to be m x minus x1 plus y1. M is still the slope, same as if it was in slope-intercept form. The tricky part is that this x1 is going to be opposite of whatever this sign is here. And then the y1 just stays whatever sign it is there. Remember with our slope, that's going to be rise over run, change in y's over change in x's. If you do need, there is the slope formula there. This is an equation that we're going to want in our formula section of our notebook. I recommend last 5 to 10 pages in your notebook. Boom, here's point slope form there. That one needs to get added in there. Now remember, when we're graphing, we're going to start with our point and then, put that on our piece of paper, or if we're on a computer, click there first, and then we're going to apply the slope. We're going to go rise over run, up however many, and then to the right, however many it is.